Alright, in this video I'm going to talk about some applications of derivatives to economics. Originally, I was planning to discuss this application at the previous live lecture, but as you know, I exhausted all time for going over the second assignment problems, so I couldn't do that. So let me do here in this video. So the very first application of the derivative is price elasticity of demand. So that appears on page number 11 of my lecture slide. So I've already mentioned several times about price elasticity, but it is formally defined as percentage change in quantity demanded divided by percentage change in price. So when we denote price elasticity of demand, we usually use the green letter epsilon. Okay, and then we use percentage change. So one advantage of using percentage change instead of standard change is we don't have to worry about the unit. So if we think about a change in price, then we may have to worry about what kind of currency we have to use. Do we have to measure change in US dollars or euros or Chinese yuan or Japanese yen or South Korean won? We don't have to worry about that because percentage change is a uniform regardless of the currency. Okay, and similar to the quantity demanded. When we measure oil, we don't have to worry about the unit, okay, or scale. So when we calculate the percentage change, so think about a price change, say from $100 to 105. Okay, so price rises 5%, and the way to calculate percentage change is we put the total change on the top, so 105 minus 100, and divided by the original price, so the previous price before change. Okay, so that is a 5%. Right? So if we consider tiny change in price, then this amount of change can be denoted by dp. Okay, using this differential dp that stands for infinitesimal change in price. Okay, and then we need to divide it by the price, the previous price. And likewise, when we compute the percentage change in quantity, if the quantity demanded, if we consider tiny change in quantity demanded, we can replace with dq. Okay, and then we need to divide it by q. So we obtain this expression. Okay, so that is a formal definition of point price elasticity of demand, or just price elasticity of demand. Okay, because it gives us it gives us price elasticity of demand at some specific point. Right? So sometimes we call that point elasticity of demand or just the price elasticity of demand, but does not matter. The formal definition is right here. Okay, so if we manipulate this quantity, then because A over B divided by C over D is going to be so A over C times D over B. Okay, so we can rewrite this dq over dp times p over q. All right, and dq over dp, if you think about this first term, that is nothing but derivative of quantity with respect to price. Okay, so that's the point. That is where the derivative kicks in the definition of price elasticity of demand. Okay, but if we think about dq over dp, because usually as price goes up, quantity demanded goes down. So price and quantity, move in the opposite direction. That is the so-called law of demand. But of course, there is some good, there are some exceptions, the so-called given good. So for given goods, price and quantity move in the same direction. But, ruling out some exceptional, some very rare cases, for most goods, price and quantity demanded move in the opposite direction. So the sign of this derivative, dq over dp, is going to be negative. So, in most textbooks, price elasticity of demand is defined as the negative of this guy. We usually put negative sign in front because dq over dp takes a negative value for most goods. Okay. So let me also put the negative sign here. Okay. Negative sign. Then epsilon is going to be positive for most goods. All right. For most goods, obeying the law of demand. So we have three subclasses for price elasticity. So the reference point is when elasticity is equal to 1, then we say demand for product is unit elastic. Okay? And if epsilon is larger than 1, then we say demand is elastic. Say if epsilon is 2, that means when price changes just 1%, quantity demanded, so if price goes up 1%, then quantity demanded drops 2%, right? So in that sense, we say demand is elastic, so sensitive to price change, okay? And on the other hand, if epsilon is smaller than 1, say, this is a 0.5, okay, 0.5, then if price change, so if price goes down just 1%, but, quantity demanded rises just a 0.5%, so, then we say the demand is inelastic, so it's not much sensitive to price change, okay? So we have these three cases, so we can divide possible cases into three like this, using this reference point. All right. So now we have one exercise about the price elasticity. So we are given by some demand function. So this demand function is given by function of quantity. So P, so the people's willingness to pay for this product, this price is given by 100 over Q minus 5. And then we want to calculate the price elasticity when quantity is equal to 5 or 10. Okay. So the way to find this, now we want to find the dq over dp. Okay. And when quantity is equal to 5, then we can easily find the corresponding price. So when quantity is equal to 5, the corresponding price is 15, I guess. 100 divided by 5, so 20 minus 5, yeah, that is 15, right? So, this guy becomes 15 over 5. Now the remaining thing is a dq over dp, right? But dq over dp is a reciprocal of dp over dq, okay? So that is the inverse function theorem. That comes from the inverse function theorem. The derivative of the inverse is going to be reciprocal of the original derivative. So using that, we can write the derivative of q as the reciprocal of derivative of p. Okay? So we don't have to find the inverse function of this given demand function. Just using this relation, we can find dq over dp. So here we are given demand function as a function of q. So we can find the dp over dq just taking derivative of this p with respect to q. Then it's going to be negative 100 over q squared. right? Because 100 over q is 100 q to the power negative 1. So now using the power, we can bring out the power. So we have a negative sign. And then take 1 away from the power. So the new power becomes negative 2. And negative power means the reciprocal. So we can just put it on the bottom and then changing the sign to the negative, or to the positive. Okay, so we obtain this. And negative 5 goes away because that is a constant. All right, so when q is equal to 5, dp over dq is negative 100 over 25, which is negative 4. Okay, so now we obtain dp over dq, but we have to put in dq over dp. So we just take the reciprocal, 1 quarter, negative 1 quarter, but we have an additional negative sign in front. So negative and negative will be positive and multiplied by price over quantity. But at quantity, at 5 units. So when quantity is given by 5 units, that's going to be 15 over 5. So it's going to be 3 quarters. Okay, so less than 1. So at quantity 5, we know that demand is inelastic. Okay, and in the same way, you can calculate the price elasticity at this quantity. Okay, let me leave this for exercise. All right, so now with that definition, let me go back to week 5 slide and illustrate the relationship between marginal revenue and price elasticity. Okay, so this is a page number 26 on the, so this is a page number 26 of the week 5 slide, I guess. Yeah, week 5, the 5th week slide. So here we have some application of the product rule. So the product rule is quite useful in producer theory, especially when we explain the monopolist behavior. So monopolist means there is only one producer in the market. Okay, so that firm has a market power, so to control the price, just like the electricity company in most countries. In South Korea, there is one monopolist, who supplies the electricity to each household. So can be thought of as a monopolist. All right. So such monopolist has a market power, and suppose that monopolist faces market demand function given by D of Q. So now price is given by some function of quantity. Okay. So given this function, we can calculate the total revenue first. If this monopolist sells Q units of product, and total revenue amounts to given price P times quantity, but P is a function of Q, so we can substitute the demand function, D over Q times Q. Okay. So that is a revenue. So that is an expression of revenue as a function of quantity. So D over Q times Q. All right, then we regard R, the revenue function, as a function of quantity, and then compute marginal revenue function. So marginal revenue means the additional revenue this monopolist can obtain, can make by selling one more unit. Okay, so if this monopolist makes some money, 100 million, by selling 100 units. Okay, so 100 million from selling 100 units. Suppose that this monopolist sells one more unit. Okay, then say revenue increases by 5 million. Okay, and marginal revenue can be the approximate marginal revenue from selling one more unit amounts to 5 million. Okay, that is the interpretation of marginal revenue. Okay. So this rate of change can be described by derivative of the revenue function with respect to quantity, because this derivative gives us information about the instantaneous rate of change. Okay, so that means when quantity changes a little bit, okay, if quantity changes a little bit, what is the corresponding change in revenue? So that is the information delivered by this derivative, or marginal revenue. Okay, so with that in mind, if we take the derivative of total revenue with respect to quantity, and observe that this is the product of two quantity functions. So using the product rule, we can find the derivative as the derivative of the first function, d prime of q, okay, and then multiply by the second function plus, leave the first function alone, and multiply by the derivative of the second, that is just 1, right? So we obtain this, okay? And let me slightly modify this one, manipulate this one, just, dividing by dividing by p. So first divided by p, and then multiply by p. Okay, so meaning that I just multiply by p over p. Okay, and then if I distribute this bottom, the price on the bottom, inside the bracket, then I'm gonna have d prime times q over p, and d of q over p. Okay, and I have one more p outside, so I'm gonna have this. Okay, but d of q, this guy, is a price. Okay, d of q is equal to price, so that is equal to 1. So this is equal to 1. Okay, and d prime can be written as dp over dq. Okay, because p is given by d over q, right? So d prime, the derivative of this, can be written as dp over dq. Okay, so we have this, all right? And then now relating to price elasticity, remember epsilon is a dq over dp times p over q, right? And we usually put negative sign in front, so negative of this is defined as price elasticity. Okay, so if we compare this definition with this quantity, you can easily find that this is nothing but negative reciprocal of price elasticity. Okay, so we obtain this. Oh, by the way, this is a typo. Not 1 minus epsilon, but 1 minus 1 over epsilon. Okay, so to summarize, we obtain alternative expression of marginal revenue. So marginal revenue can be expressed as price times 1 minus 1 over epsilon. Okay, so from this, we obtain the following insight. If epsilon is a large number, okay, if epsilon is a large number, then 1 over epsilon is going to be a very small number, so marginal revenue will get larger. Okay, so when demand is quite sensitive to price change, by selling one more unit, the monopolist's additional revenue, increment of revenue, will get larger and larger. Okay, so once again, as epsilon increases, okay, marginal revenue gets higher. Right? So what is the economic intuition behind this result? Okay, so once again, price is marginal revenue equals price times 1 minus 1 over epsilon. Okay, so marginal revenue and epsilon move in the same direction. Okay, why that is true? Because think about so think about putting price on the vertical axis and the quantity demanded on the horizontal axis. Consider some demand function that is a almost horizontal line. Okay, and for this type of demand function, price elasticity is really high because although price changes a little bit, okay, the quantity demanded, people reacts quite substantially to even to a small change in price. Okay, so given this demand function, now suppose that monopolist increases quantity by 1 unit. Okay, so the current price is P naught. Okay, and then monopolist sells Q naught. Okay, as much as this. So the total revenue is going to be area of this rectangle. Right? Now, monopolist sells 1 more unit, so increases the quantity produced just by a little bit. Okay? Then, in order to make a revenue, so in order to sell this additional unit, monopolist has to decrease the price. Otherwise, this additional unit will not be sold. So, has to decrease the price, but in case of this kind of demand function, when price elasticity is really high, the monopolist just decrease the price a little bit, okay? Because people is quite sensitive to change in price, okay? So just by decreasing price a little bit, the monopolist can sell this additional unit, right? So what is the corresponding change to revenue? Now the revenue becomes the area of this black rectangle. Okay, so we can see that revenue decreases by this amount, but increases by this amount. Okay, so this is called the price effect in economics. So price effect means that once again, in order to sell 1 more unit, the monopolist has to decrease the price. Otherwise, the people does not buy this additional unit, right? So, but this monopolist cannot do price discrimination, meaning that cannot impose different prices to, different customers. So, if the monopolist just charges a uniform price, the whole uniform price will go down by a little bit, so decreasing revenue. So that is a price effect. The quantity effect is because now this monopolist sells 1 more unit, so there will be some increment of revenue. That is called a quantity effect. Okay? This is a quantity effect. So when demand function looks like this, so price elasticity is really high, then you can easily see that this quantity effect overwhelms the price effect, so marginal revenue will increase. Okay, so that is a intuition behind this negative relationship, this positive relationship between marginal revenue and price elasticity. Okay, when elasticity is really high, quantity demand overwhelms price effect. Okay, so that is the one more application, and the last application is the application of the quotient rule to figure out the relationship between marginal cost and average cost. Okay. So in microeconomics, when we study producer theory, there are two important functions. The first important function is profit function. Profit function tells us by selling Q units, what is the highest profit for the firm. Okay? So what is the highest profit, the firm can accrue. That is a profit function's definition. The other important function is a cost function. So cost function denotes the total cost necessary for producing Q units. Okay? So regarding this cost as a function of Q, okay, if we divide the cost function by quantity, so C of Q divided by Q, it tells us average cost, right? So if total cost is 1 million, so I need $1 million to produce 10,000 units, then the corresponding average cost is going to be, why do I choose 10,000? So this quantity tells us the average cost. Okay, by producing just 1 unit, what is the cost on average? Okay, so average cost. And if we take the cost function and take the derivative with respect to Q, we obtain marginal cost. So that is the derivative. So just by producing one more unit, how much cost I have to incur more. So that is a marginal cost, right? And there is a remarkable relationship between this average cost and marginal cost, which is whenever average cost function is decreasing, MC, or the MC curve, so this curve, is always below the average cost function. Once again, average cost function is decreasing. So in this region, average or marginal cost is always below the average cost function. But whenever average cost function is increasing, now marginal cost is above average cost. Okay? So as a result, marginal cost function always passes through the minimum, the lowest point of average cost function. Okay? As is displayed in this figure. So, this point is usually called the minimum efficient scale, because in this example, by just producing 60 units, the firm can minimize average cost. So, when firm produces 60 units, the average cost will be minimum. So the production operation goes the most efficiently. So we call that minimum efficient scale. Okay, but it turns out that marginal cost always passes through the lowest point of average cost function. And then we can demonstrate that using the quotient rule. So in order to demonstrate, now we derivative of the, we take the derivative of average cost function with respect to Q. Okay. Then average cost function is defined as total cost divided by quantity. And then we take the derivative. All right. Then using the quotient rule, now, the top and bottom is a function of quantity. So to find the derivative, we use the quotient rule. Then we obtain Q squared on the bottom. Okay. And on the top, C prime times Q minus C over Q times 1. Right? So just the C over Q. Okay, so we obtain this. Now let me manipulate a little bit. Just a, if I'm factoring out Q from the top, then Q comes up front, then I will be left with a C prime, but that is a marginal cost. Okay, and then C over Q divided by Q, that is average cost. Okay, and then divided by Q squared. Okay, so I can cancel out Q, does not matter, but just to simplify the expression, so Q on the bottom and MC minus AC on the top. Okay? So the Q, the sign of the denominator is always positive. This is this stands for quantity produced. So this is always positive, meaning that derivative of the AC will be positive whenever MC is higher than AC. Okay? So dAC over dQ will be positive if and only if MC is higher than AC. Okay? And now we consider the meaning of the sign of the derivative. If the sign of the derivative is positive, we know this curve, average cost curve, is increasing. Okay? But if the sign of the derivative is negative, okay, then the curve is decreasing. Okay? So the negative sign of this